I want you to learn. I want what's best for you.
The best for me is learning how to count cards.
Yeah, well, there might be. So, we started with talking about polynomials, right? We talked about monomials, binomials, trinomials. We talked about the degree and all that stuff in the warm-up. Now, yesterday we talked about how we add and subtract polynomials. So what do you think we're talking about today? Well, I mean, it's not important. But also, if you think ahead, it kind of makes sense. Today we're talking about multiplying and distributing, yep, but not dividing. Someone can read the board. Good job. So our learning targets for today. Students will be able to multiply binomials using the distributive property, a table, or the FOIL method. So one thing I should make clear before we start, we're going to look at different ways that you're able to multiply polynomials. But really the most important one, and the one that we need to make sure that we know, is the FOIL method. How many of you guys have heard of the FOIL method? Does that word sound not at all? We haven't seen it? Okay. Students will be able to multiply binomials and trinomials. So we don't use the FOIL method necessarily to do it, but sometimes we're going to have a binomial, so two terms, and we'll need to multiply it by a trinomial. So three terms. Right? Super sweet. Okay. Order of operations, which I still think is super clever. We're going to review. We have three methods to multiply that we're going to look at. We have a couple of examples, and then we have some practice. Okay? Very, very similar to yesterday. Now, what is... Oh, wait. So I have the full effect here. I need to change. Single page. Yes, that's what's here. Okay. The distributive property. What is the distributive property? Or give me an example of the distributive property. Okay, parentheses. Numbers in. What numbers do you want?
I want 1 and 3 plus.
Okay. What else?
Oh, you should put it 2 in.
Okay, and what would the distributive property let us do?
You do. Oh, 2.
No, keep going, Sky.
You do 2 and 1.
So we distribute here,
And
2 times 3, our plus sign comes right down, and we have 6, right? That's the distributive property. Very good. We're going to use that same idea, except with our binomials. So, same idea, we're going to have something with parentheses, and we're going to have something over here with parentheses, and we're going to have to distribute each number to the rest of them. Everyone wants a piece. In case you didn't get it, that is the distributive property, but you guys nailed it, so I didn't even need this slide. Good job. Now I can go back to the other view.
Is that what it's going to look like?
No, they won't be this.
Oh, no. Sorry. That's messed up.
So first, yesterday we talked about the vertical method when we're adding and subtracting. Remember we lined up our like terms and all that good stuff. We have a vertical method so that we can multiply these binomials, but there's a little bit more to it. Alright, a little bit more to it. So when we look at this problem, we have x plus 3 multiplied by x minus 4. Okay, you can see over here they put x plus 3 over x plus 4, and yesterday when we were adding we had an addition sign over here, but today we're not adding, so we have a multiplication sign. Just like with regular multiplication, first they did negative 4 times 3 to get negative 12, and negative 4 times x to get negative 4x. So just like it says in this box, we are really doing negative 4 multiplied by x plus 3. So very similar to normal multiplication. And then in the next line, just like again with normal multiplication, we put our 0 in. Now we're going x times 3, x times x. Like it says over here. You could think about it like setting up x times x plus 3. We're distributing. Or like I drew over here, think about it like we're doing regular multiplication. The vertical method, I mean, it makes sense, and I get some people might use it, but it's not the easiest.
But it's the coolest, so.
It is maybe the coolest. That could be true. Yeah. After we multiply each of the bottom numbers by each of the top, then we just add like we were doing yesterday. So we make sure our similar terms. Laman, I don't know how you're learning when you're staring at tab. Pull your seat up to your desk, please. Face forward. All the way up to your desk. I know being close to tab is not good news for you. So sorry, tab. Now we have our like terms lined up. Our negative 12 or minus 12 just comes straight down. Minus 4x plus 3x just gives us negative x, and we have nothing to combine with x squared. That is the vertical method. Again, you will not have to know all of these methods, but you need to be able to, the goal is that you're able to multiply these binomials. Okay? And I'm going to show you a couple different ways to do it, and you just need to choose and be able to do one of them. Probably the easiest and most common will be the last one that we look at. So don't be freaking out if you're not understanding. Do we have any questions on that right now? Okay. So, use the vertical method to find the product. First, we're going to line up our binomials just like we would if we were multiplying. Now we have 6 times negative 2 gives me negative 12. 6 times z gives me 6z. I put my 0 in, so I move over one spot. Now I have z times negative 2. Negative 2z, and z times z gives me z squared. Negative 12 plus 0. 6 plus a negative 2 gives me 4z. And then we have nothing to combine with z squared. Questions on that example? Okay. Now it's your turn. Go ahead and take about a minute. One of your practice problems. Take about a minute. Line these up and multiply. I'll at least get you started with the setup. Our setup should look like this. Setup should look like that.
Hey, yo, this is the setup?
That's the setup. Yep.
That's a gnarly setup.
I think.
How good was that setup? Never heard you say
So other way around. We do this first, right? We want to line up my terms. Do the same. Now our like terms are what you write with 4 times y. Right, that was good. 4 times. Just times y. Just regularly times y. You do good.
Now your light turns more like them, right? So now you can draw your line across and just add down. Good. Yep, good. Nice job. Yeah.
So, I'll lead you up all the way to the end. We have 1 times 4 that we're starting with. Gives us 4. 1 times y gives us y. We put in our 0. Y times 4 gives us 4y. Y times y gives us y squared. We have no negatives. Now you just need to add down, which will be your job. Which part? All of it. After the y plus 4. So we put our 0 in just like if we were multiplying, right? We multiply regular numbers. You put a 0 in to hold your place value. And then we take this y on the bottom, and we need to multiply it times 4, and then multiply it times y. I mean, like if you're doing 12 times 14, you first multiply 4 times 2, 4 times 1, we put our 0 in, and now we have to go with this second number. 1 times 2, yeah, 1 times 1. It's the same idea. We just have letters and additions. Well, you need to add down to simplify. Alright, so you need to add those down and simplify those terms. Our second method, yeah. So you're close. Our second term, the table method. This is not the way that I would choose to do this either, but I'm presenting it to you, and you can decide which method you would like. The table method. Step 1, we start here. Okay, those are the binomials that we were multiplying together, and they put them in a table. So you can see this is just 2x minus 3, and they put each term in the table. This is just x plus 5, and they put each term in the table. Now, then they go 2x times x gives me 2x squared. 2x times 5 gives me 10x. And now they move to 3, or negative 3. Negative 3 times x gives me negative 3x. Negative 3 times 5 gives me negative 15.
Yo, what?
That's right, the best is yet to come, so.
I think I'm just gonna look at account card.
This is gonna be a great.
Don't sweat it yet. There's no reason to get worried. But do we see how they put each term into the table? You don't. Well, you gotta follow with me because I break the whole thing down. Don't just look at the whole table. Right. Look, we have the term 2x minus 3. We have 2 terms. It's a binomial. We have 2x and we have negative 3. We put one of our terms in the top spot of our table, the other one right next to it. Right? We're just splitting up the terms. X and 5. We're just splitting up our terms. Now, we just like with the table that you'd see like when you're doing something squared, Putnam squared in science class. 2x multiplied by x would give me 2x squared. 2x multiplied by 5 would give me 10x. Negative 3 multiplied by x would give me negative 3x. Negative 3 minus, or negative 3 times 5 would give me negative 15. So you're multiplying each term by the other term. Use tables before. Now, the last step would be to simplify this, right? If we look at what's left in the light blue part of the table, we have 2x squared, which is the only like or term of its kind. We can't combine it with anything else, so that's gone. We We have a negative 3x and a 10x. Those are like terms, so we could simplify them. And then we have a negative 15.
Yes, use the table to find the product.
We're using the table method to find the product. I put each of my terms on the table. P multiplied by P gives me P squared.
P squared? Squared.
Multiply each term by the other term. And then we can simplify. So P squared is the only term of its kind. We have a 3P and a negative 8P. Gives us negative 5. And just 24 is left. You got it? This isn't even the easiest way to do it. That's a good guess. Well, it's kind of. It would be contradictory. 22. You're almost done. Oh, actually, it starts with like number 20. Yeah.
I did that all in my brain.
Yeah.
No big deal.
That's a
Your second practice problem. Use the table method. Don't quote me on this, but I believe this is the only time where I will force you to use one of the methods. So I want to see that you've been paying attention. You can do these once.
I've been paying attention, but I'm supposed to
Hey,
make
you're still not facing the board. I don't know if we're really engaging ourselves in it too much. I think we're watching. We're not really engaging our minds. No, you guys are great. And then still simplify it right now. Wait, what? Yeah, you guys.
Why is that one?
This is what your setup should look like.
Oh, I don't know.
All right, last method.
Ah,
And
yay!
you'll have time to finish those. If you have been lost up to this point, or if you have not been engaging your mind in what we've been talking about, it's time to. Now's the time to tune in. This is what we need to know. All right. This is the number one method. You'll use this for the rest of your math career. This is what we have to know. Correct? And this is just called the FOIL method. So, FOIL stands for first terms, outer terms, inner terms, and then last terms. All right. So when we start with our binomial, you can see we're starting here. We start with the f. So we start with our first terms. So the first term in each binomial, so x times x, and we multiply them. Then we go with the outer terms. So the outside of the first times the outside of the second. The inner terms. And then the last term. So the last term, the first binomial, and the last term the second binomial.
So what did you do with the other thing again?
With which one?
The average.
We're multiplying. All of them are multiplying.
Oh, okay. No, no.
So we call it the FOIL method. Is just an easy way to remember it. Eventually, it will become a little bit of a habit. Don't write down this example. I'll show you an example right after this.
I like the boxes. I like the boxes.
I'll show you an example right after this. That will be a little bit nicer.
Easy.
Again, do not write down that whole example. If you want to write down the meaning of FOIL, then do that, but don't write down that whole example. Here's the example that you should write down. So it says find each product. Well, there's only one, so find the product. So what is the F in FOIL stand for? First terms. So we're starting out by multiplying the first term. So x multiplied by x. Well, we'll simplify in a second, but yeah. Yep. Now what is the O? Outer. So now we go with the outer term. So now we're going plus x times -6. You need to not forget that negative sign. Now what does the I stand for? Inner. So we have -3 multiplied by x. So plus -3 times x. And the last, the L stands for outer. Last. There you go. The last term in each one. So we have now -3 times -6. Now we need to simplify. So x multiplied by x would give me x squared. Plus we have -6 times x is just -6x. -3 times x is -3x. And -3 times -6 would give me -18. Can I simplify any more? Who said yeah? Someone said yeah. What can I do to simplify more? Yeah, those are like terms, -6x and -3x. So if we were to simplify it all the way one more time, we would have x squared minus -6x minus 3x would give me 9 minus 18. So every time after we FOIL, we still have to simplify one more step. What do we think of that one? That one's better? No? The first one was probably the most confusing. The table method is pretty good. This is the one that we need to be able to nail. We'll use the most. You can use it, yeah, but eventually we'll need to be able to use the FOIL method. So last practice problem. Use the FOIL method to find each product. So you have 4 problems total. I need to see those, and then I'll whisper to you what the assignment is for the rest of class. Yeah.
Wait.
What?
I wonder what it could be.
Not like big idea. It wouldn't get this paper, right? Not a big idea.
I don't know. You're gonna have to get it done to find out.